Alright guys, so we've talked about ionic compounds. Let's look at our next type of compound, which are acids. Acids always start with hydrogen. The only exclusion to this is H2O is water, technically is not an acid, but we can talk about that a little bit later. Basically what you need to know is if you see a compound that starts with hydrogen, it is an acid. Okay, and that's the easiest way to identify them. We'll talk about this a little bit more in the next video, but ionic compounds typically start with metals, acids typically start with hydrogens, and that kind of allows us to be able to see the difference between them. Okay, we've got two different types of acids. We have a binary acid, which is any acid that does not contain oxygen in it, so like H2S, HCl, HCN, etc. Binary typically means two, so two different elements, there we go, hydrogen and sulfur, two different elements, hydrogen and chlorine. Cyanide is one of the exceptions to that because it is a polyatomic ion, but still considered binary because it does not contain an oxygen. Oxyacids do contain oxygen, and specifically they contain a polyatomic ion with oxygen in it, so like H2SO4, HClO3, HNO3, and of course you have two different types of SO4 and SO3 that you have to keep track of, and don't worry about the more oxygens, the stronger the acid. That will come in a later chapter. Okay, so how do we name binary acids? Okay, well, binary acids start with a prefix of hydro. Hydro is our key to identifying from a name if it's a binary acid. Hydro literally means no oxygen. Okay? Hydro literally means no oxygen present in a thing. Once we have the hydrogen, we name the element. We change the ending of the element just like we did with ionics to IDE, but instead of IDE, we change it to IC, ic. And of course, acid is the second name. Hydro does not tell us hydrogen, so please keep that in mind. Hydro tells us that this compound does not have an oxygen present in it. Okay? Acid tells us hydrogen. Hydro tells us no oxygen. Okay, so keep that in mind. So let's look at these. HF, no oxygen, so it's binary. So we say hydro to represent no oxygen. Fluorine becomes fluoric. Change the ending to IC. And then of course, because it starts with hydrogen, we give it the name acid. So hydrofluoric acid. Okay, HBr, hydro, because there's no oxygen. Bromine becomes bromic, and then of course acid at the end of it. Okay, the 2 and 3 we see here come from charges. Sulfur has a -2 charge, hydrogen has a +1 charge, so H2S, we still treat it with charges just like we do ionic compounds. And of course we name these just like we do these guys up here. So again, no oxygen, so hydro. Sulfur becomes sulfic. Our sulfuric is correct as well. And then of course acid is our second name. Hydro again for this guy. Nitrogen becomes nitric, and acid. Cyanide, kind of one of our weird ones because it's one of our only binary acids that has 3 elements in it instead of just 2. Cyanide has no oxygen in it, so we still say hydro. We say cyanic instead of cyanide, and then acid. Okay. So binary, working them backwards, you just simply look at the charges. So hydro tells us no oxygen. It means we're looking at the periodic table. Hydrophosphic tells us phosphorus from the periodic table with a -3 charge. Acid tells us hydrogen out in front. Cross and swap, H3P. So let's try some of these as well. Hydroiodic. Hydro tells me I'm looking on the periodic table. Iodic tells me iodine. So I've got I with a -1 charge. Acid tells me there's a hydrogen out in front. Kind of think of it as the first name is the technical last name. Okay, if you will, acid should be the first name, but it comes last. Cross and swap, we get, let me try that again. We get HI. Okay, hydrosulfuric or hydrosulfic. Okay, both are correct terms or correct names, so don't worry too much about the UR. It just depends on how you pronounce it. Hydrosulfuric tells us we're dealing with sulfur, which is -2. Acid tells us hydrogen. Cross and swap, H2S. Hydrophosphuric or phosphic, either one. Acid tells us hydrogen. Hydrophosphuric tells us phosphorus. -3, H3P. Hydrocyanic, we've already done, HCN. It's on the last slide. Okay, now let's talk about oxyacids, our second type of acid that contains oxygen. Okay, if it contains oxygen, it contains a polyatomic ion. So our first step is to determine if the polyatomic ion ends in 8 or ite. If it ends in 8, we change it to ic. If it ends in ite, we change it to us. And one of the ways to remember that is I ate it and it was icky, so 8 and ic. Don't have a clever saying for ite, I apologize, so you have to remember 1 goes to ic, 1 goes to us. If you can remember 8 goes to ic, you can remember ite goes to us. So here's some examples. H2SO4, again, you can circle or put parentheses around your polyatomic ions to help. SO4 is sulfate. ATE goes to ic, so it becomes sulfuric or sulfic acid. SO3 is sulfite. Ite goes to us, so it becomes sulfus or sulfurous acid. Let's try some of these. If I can get my slide to change. There we go. H2CO3. So we see the oxygen, it contains a polyatomic ion. Identify the polyatomic ion. It's CO3. CO3 is carbonate, so carbonate becomes carbonic. We change the 8 to ic. And we add acid as our second name. NO2 is our polyatomic ion here. Again, oxygen, so we know there's a polyatomic ion. NO2 is nitrite, so it becomes nitrous acid. ClO4 is perchlorate, so perchlorate becomes perchloric acid. And you just kind of keep going from there. Something to make note of. HBRO, BRO is hypobromite. Hypobromite. Hypo is not the same thing as hydro, so be careful with that. Hypobromite becomes hypobromous, and then acid as a second name. Okay, let's look at working these backwards. Same thing, we look at our charges. Phosphoric acid, notice the lack of hydro, which tells us we're looking at our polyatomic ion list, not the periodic table. It means there is oxygen. Ic tells us it came from 8. Okay, well, phosphate is PO4 -3. Acid tells us hydrogen. Cross and swap, H3, PO4. Let's try some of those. No hydro tells us polyatomic ion. Ic tells us 8, which is NO3, -1, nitrate. Acid tells us hydrogen. Cross and swap, HNO3. Chlorus, no hydro, chlorus tells us ClO2, chlorite. And that also has a -1 charge, hydrogen +1 because of the acid, HClO2. Okay, carbonic ends in IC, came from 8, no hydro tells us polyatomic ion, CO3, -2, throw hydrogen out in front, cross and swap, H2CO3. Okay, let's see if we can identify them all together, all kind of mixed up. So the first one, notice hydro is at the front. Hydro tells us it is a binary acid. It tells us we're looking at the periodic table, not our polyatomic ion list. So hydrophosphoric tells us we're dealing with phosphorus, -3. Acid tells us hydrogen. Cross and swap, H3P is hydrophosphoric acid. Nitric acid, notice no hydro tells us polyatomic ion. Ic says it came from 8. So hydrogen out in front because of the acid. NO3 for nitrate, cross and swap, HNO3. Sulfurous, again, notice the lack of hydro, tells us polyatomic ion, is SO3 -2. Sulfite, not sulfate because it's us, sulfite. Acid out in front because it's hydrogen, H2SO3 is our compound. Notice the hydro, tells us periodic table. Hydrogen out in front because it's an acid. Hydroiodic tells us iodine, which is I-1, cross and swap, HI. Okay, and we just did carbonic acid, but we'll go ahead and do it again. No hydro tells us polyatomic ion. Ic says it came from 8, so CO3, -2 is carbonate. Hydrogen out in front, H2, CO3. And that's about it for acids, guys.